Swayam Prabha. Digital India. Educated India.
Dear students, I welcome you again to the lectures on the course material of Transportation Engineering 2. In this course, already we have discussed about some of the specific and important issues of railways. We have already discussed about the permanent way, the gauges, the stresses and the resistances offered by the permanent way, and then we have discussed about the different components, the rails, the sleepers and ballast, the specific issues related to those components. Like in the case of rail, we have discussed about the wears and damages or the failures. We have also discussed about the creep of the rails. We have discussed about the conning of the wheels. In sleepers, the specific aspect has been the sleeper density. And then in the case of rails, another thing which has been discussed is the joints. In the previous lecture, we have discussed about the various fixtures which can be used to connect all these components, and specifically the rail with rail and the rail with sleepers. Now onward, whatever material which we will be discussing is related to the geometric design of those railway tracks. In the case of geometric design, the very first thing which we are going to discuss is alignment of track. Now, in the case of this lecture, the lecture has been outlined with geometric design elements, the alignment of track. Now, the geometric design is defined as the design of all the physical features which have been provided so as to have a smooth operation of the system. Now, these physical features may be different things which are provided so as to have a straight connectivity, or so as to have a curved connectivity, or so as to provide connectivity on any gradient. So, looking at this requirement where the connectivities have to be provided between the two places or the 2 points, we have to look at different aspects. We have to look at what is the distance between them, what is the location with respect to each other, and then on the basis of those we have to decide about different elements. Now, the various elements which can be talked about is in the case of the alignment of track, we have 2 things other than the straight portion which is provided and designed. In the case of a straight portion, the main thing is that we are providing the rails at a certain gauge distance depending on what gauge is already being selected for the construction of that railway track. Now, the other thing other than the straight section is curve. There can be 2 types of curves, one is horizontal curve, another is vertical curve. Now, apart from these things, the another element which is of a very high significance and importance is the speed. Speed of the train and its effects. Some of the effects we have already discussed when we discussed about the stresses and when we discussed about the resistances. We have seen that whatever resistances or stresses are provided or they are being offered by the track or the components, there is an augmentation in the value of those stresses or resistances as soon as the speed is connected to it. So, therefore, the effect of speed is another important aspect which needs to be discussed in detail. Now, within the horizontal profile, what are the various things which can be discussed or may have their importance, or by which they are going to create an effect are circular curves, the super elevation, transition curves, widening of track, and track and platform clearances. So, it means we have to discuss these aspects one by one when we take up the horizontal profile, where the movement or the change in direction in plan is being provided using the circular curve. Now, as soon as there is a curvular motion comes into picture, the centrifugal force will also be coming into consideration, and so as to nullify the effect of this centrifugal force, the super elevation has to be provided. Then the another aspect, another design feature which is to be provided and designed is the transition curve. The transition curve is the curve which is provided between the straight portion and the curved portion, and it has a tendency to provide the smooth transition from the straight section to the curved section without showing any point of jerk or without creating the problems of comfort. Further, there is a requirement of widening of track because of the rigidity of the wheelbase of the wagons or the locomotives. So, we have to look at the widening of the track because of this aspect, and there are certain other reasons due to which this widening is to be provided, like in the case of super elevation, when the wagon or when any of the vehicle traverses this super elevated track, then it has a tendency to lean in the inward direction, and due to this certain clearances on the inward side of the track has to be provided. Similarly, there may be a requirement of providing the clearances between the tracks if there are more than one track being laid simultaneously or parallel to each other, or there are some clearances which have to be provided between the track and the platform. So, in the horizontal profile condition, all these design elements will be discussed further into detail, whereas in the case of the vertical profile, the things which needs to be discussed are the gradients and their effect. Gradients means it's a value or it's a way by which the 2 points which have been placed at different elevations can be jointed together, and that is what is the gradient. And when this gradient is provided and along with gradient a curve is also being provided, then as we have seen in the case of resistances, wherever there is a grade provided, it offers grade resistance. Similarly, wherever there is a curve provided, then that curve offers a curvature resistance. It means when the gradient and the curvature both are being provided together, the resistance increases to a much larger value. And so as to negotiate this type of a curve, a grade compensation has to be done. So, in the case of the gradients, the grade compensation is the another aspect which will be discussed. And further, wherever the two gradients are meeting each other, at that point we cannot provide a sudden changeover from one grade to the another grade. So, due to this aspect, at this particular point a curve is to be provided, and because this curve is provided in the vertical profile, that is why the name of this curve is given as vertical curve. So, these are some of the design elements which needs to be taken into consideration in detail. Another important aspect, as we have discussed just before, is that the speed of the track. There are number of design elements within these vertical profiles and the horizontal profiles, that is when we have to design the curve, when we have to design the vertical curve or the horizontal curve or the super elevation or the transition curve. In each and every aspect, the design speed of the track has to be considered, and that is what is the significance and importance of the speed on the track. So, therefore, the another feature which is to be taken into consideration is what are the different types of speeds which can be provided on the track, how those speeds can be computed, and further how that speed contributes towards the design of the geometrics of any railway track or a permanent way. Now, coming to the necessity of the geometric design, the geometric design has to be provided so as to provide a smooth and safe running of trains, because if the geometrics are not being provided, then the connectivities which are provided between the rail sections or the directions in which the rails have to move or the changeover of the direction from one side to the other side, all these things will not be possible. At the same time, if we are not providing the transition phases between different elements, as we have seen previously, like in the case of the curve, the transition curves needs to be provided between a straight section and the curved section, then also there will not be a smooth running, there will be a point at which the jerk will be observed by the passengers or the freight being moved. Further, if the super elevation etc. is not being designed, then in that case, because of the centrifugal force and the effect of that centrifugal force along with the higher speed of the trains at which they are moving, there are always chances of overturning or derailment of the trains. So, that is the safety aspect due to which the geometrics needs to be designed. Another aspect is the maximum speed. We cannot run the trains at any speed. We cannot run the trains at 500 kilometers per hour or 1000 kilometers per hour without designing a track for that specification. Of course, in today's conditions, we have the test tracks on which the trains had been run at a speed of 500 and 550 kilometers per hour. Though in Indian conditions, we are not having any track on which the trains have moved to such a distance, or even they have been moved at a value of above 160 kilometers per hour. So, this is one aspect which needs to be taken care of, and we have to decide what is the maximum value up to which the trains can run on any of the track. Further, there is a need to carry heavy axial loads, and when we are carrying the heavy axial loads, then the system has to be designed in which those loads are not getting synced in below, or there are no undulations which are getting created because of the movement of such heavy loads. Further, another aspect of this design is the avoiding accidents or the similar sort of hazard shapes like derailments. This is another reason due to which the geometrics have to be designed. Then once the geometrics have been designed in a proper way for certain values where the tolerances being provided, then the maintenance requirements will also be lesser, and therefore, it reduces in the overall cost component of the track. And finally, the last thing which is of importance in this case is good aesthetic value. What happens is that if a smooth design is being provided, and if that design is looked upon in plan from the top or in elevation, then it gives a sense of aesthetics, and due to this reason also the geometrics needs to be designed and provided. Now, coming to the main point in this lecture is the alignment. Now, alignment is defined as the line in space through which the connectivity is provided between two places. Now, this line in space means there are 2 points which have been provided at any 2 locations. They may be at the same elevation or they may not be at the same elevation, and if we provide a connectivity taken into consideration certain locational aspects, certain safety aspects and economic aspects into consideration, then whatever is being finalized, that is the location of a line or the center line of that facility in space, and that is what is alignment. And on the basis of this alignment may be, as we have discussed previously, can be horizontal alignment or vertical alignment, depending whether we are talking it in terms of a plan or we are talking in terms of elevation. Now, whatever alignment is provided in whatever form, there are certain things which are the basic requirements of any of that alignment. The very first thing is the purpose of that line or purpose of that alignment. It means is that for what reason that alignment has been provided between the 2 places, whether it is having that route is being provided or alignment is provided so as to move the commodities from the place where they have been produced to the places where they are going to be consumed, where it is going to work as a connectivity for the mainly the passenger traffic, or where it is going to work as a point of tourist attraction in that area, like in the case of hill railways where they have been provided like in Shimla or Darjeeling or Nilgiris in Uti. So, they are also the tourist attractions in those area, or like in Matheran. So, we have to look at for what reason we are designing or for what reason we are providing that alignment, and once that alignment is being provided or being fixed or implemented, then whether it is fulfilling that purpose or not. Another thing in this is that it is not necessary for only single purpose a route or alignment has to be provided. At times there may be a combination of the things, like both the things, passengers and the freight, may move along that alignment instead of only a single thing being moved. So, that means there is multi-purpose condition where that alignment is being provided. Another aspect is that it should be helpful in the overall integrated development of that area in which it is being provided. It should not act aloof than the other developmental aspects or the other developmental works which are going on in that area. The main thing is that it should act as a part of the overall development instead of working as an individual aspect. Now, if it acts as a part of the overall development, then only the whole thing will feel integrated, coordinated, and it will be a comprehensive sort of a planning or development in which it will be working. Another aspect is the shortest route should be there as far as it is possible. This shortest route is to be provided from the economic considerations. If we have point A and point B, and if we join those point A and B by a straight line, then this is what is the shortest route. But not necessarily every time it is possible so as to go for this shortest route. Sometimes we find that there are some physical features in between those 2 points which are not permitting us so as to draw a straight line or so as to provide the straight alignment between those 2 points. Like there may be a hillock in that area, or there is a lake in between those 2 points, then it is not possible so as to draw a straight line. Or if we have to do that, then certain other technologies needs to be used, like in the case of hillock, if we want to move through that one, then a tunnel is to dug, whereas if the lake is to be crossed, then a bridge is to be provided. It means there is a combination, some more technologies which have to be used so as to provide that facility along a shortest route. But what we have to see at this point is whether provision of a shortest facility with the combination of other techniques is cheaper, or it is cheaper so as to traverse alongside of those obstructions and provide a connectivity. So, it is not necessary that every time a shortest route can be provided between the 2 points. Sometimes the other aspects needs to be taken into consideration. These aspects which needs to be taken into consideration may also relate to the safety point, which is another point. As we talk about the hilly area, it is not at all possible to provide the point which is at the top of the hill connecting directly with the point which is at the foot of the hill. What we do in those cases is so as to maintain the safety or maintain the safety of the rolling stock. We provide a circuitous route which moves maybe along the side of the mountain, and that is how the distance has been increased, but the safety is being maintained. Similarly, the another aspect which is to be taken or which needs to be given due consideration is comfort. In the case of comfort, we have to see that the route passes through that area where the possibility of getting the jerks, the possibility of getting the undulated surfaces is less as possible, and that is from where the comfort is to be generated, or otherwise the technology is to be used so as to provide comfort along that alignment. And finally, as we have just discussed before, that aesthetics is another basic requirement in any of the alignment. The alignment, if drawn in plan or if seen in elevation, should provide a view which do not look like a severance to the visual aesthetics, but it should be a thing which can be adored or which can be praised of for for that type of design. So, these are some of the requirements which needs to be taken care, but at the same time there are certain things by which we have to make compromise on all these. Of course, one more point which is there in the case of the basic requirements is the overall cost of the alignment. As far as possible, the overall cost of the alignment should be as low as possible, and this is what is being given here. When you talk about this economic consideration or the overall cost, then it is to be talked at three levels. One is the construction level, another is the operational level, and third is the maintenance level. Now, when the route or when the alignment is being constructed, then we have to look at various aspects by which the overall cost of the construction can be reduced. It includes the machinery, it includes the manpower, it includes the material, everything. In the case of operational cost, the alignment should be such that their fuel requirement or the wearing of the various components of the system is as minimum as possible, and if that can be done, then the operational cost will reduce by itself. Similarly, whatever design features have been designed, another aspect is that what type of design is being used and whether that design requires a regular maintenance or whether it requires a periodical maintenance. If a periodical maintenance is there, by which even by 3 months or after 4 months only a maintenance is to be done, then obviously in this case also the cost of maintenance will be reduced, and that is how we can have a minimum cost of overall alignment which has been constructed, and this is to be taken into consideration. Now, we come to the another point, that how we are going to select any alignment. There are number of factors which governs the choice of alignment, which governs the position of the alignment through which it is going to pass and through in which direction it is to be placed. In this sense, the first point is the choice of gauge. Now, the choice of gauge is going to be governed again, of course, by the different factors as being seen before. The choice of gauge may be like whether we are interested in providing a broad gauge or a meter gauge or a narrow gauge or any other gauge, like in the case of the hilly region, whether we are interested in providing a hill gauge. And all these gauges, they are having different values starting from 1676 mm to 610 mm. So, that is what is the variation between the gauge. So, which gauge is to be provided? Now, this choice of gauge is also governed by the purpose for which that alignment is being constructed. If there is a heavy load which is to be transported from one point to the another point of this, as we have discussed about an example that there is a point of production and it is to be connected to a point of consumption, then obviously in that direction there will be heavy load which will be kept moving throughout the year. So, in that case a bigger gauge is to be provided, that is what is the broad gauge is to be provided. Whereas, if the traffic is very less or it is to be provided just so as to provide a connectivity between those two points, then a smaller gauge can also be worked on. So, a meter gauge or a narrow gauge can be provided in such cases. The another condition is that we have to look at the choice of the gauge on the basis of the physical features or topographical features of that area. On the basis of those physical or topographical features, if it is a plain area or if it is a hilly area, of the obvious choice of a gauge will differ. So, we may have a broad gauge in the case of a plain area, but the same broad gauge may not be provided in the case of a heavy hilly area or a mountainous region where the steep gradients are being provided. Then the next point is the obligatory points. Obligatory points means those locations or points through which the gauge through which the alignment has to pass, or there may be some conditions in which the alignment cannot pass through those points. So, we have to look at both the conditions. We have to look at through which the alignment can pass or cannot pass. In case we take the important cities, then the important cities are the locations through which the alignment has to pass. Similarly, as we have seen that there are certain physical features which creates an obstruction to the movement like lakes or say the hillocks. So, at these locations the bridges needs to be provided or the tunnels need to be dug. So, if we are looking at this type of a condition, so we have to go for a major bridge, so or we have to provide the some type of a crossing at that position. Similarly, we can talk about the crossing with respect to the road. So, that is a level crossing which is provided at that location. So far it is possible, so as to avoid that type of crossing, the crossing is avoided, but if it is not at all possible, then we have to use the technology and provide another feature, that is like bridge. In the case of passes or saddles, or in the case of a mountainous region, then we have to go for the tunnel sites. So far it is possible, we use passes between the mountains so as to run our alignment, or the alignment can run over the saddles, so that because they are the point of watershed conditions. So, we have the ups and downs, and at all if it is not possible and there is a big mountainous range which is coming, then the tunnel is to be provided, and therefore, we have to locate the site where the tunnel can dug, and still it is not a big length in which the tunnel is to be cut, because the tunnel operation is a very costly affair. Another aspect is like another place which needs to be considered is a religious place. If there is any religious place which is coming along the alignment or where the alignment has to cross that, then we have to omit this type of place. And in this condition, we have to go round that place, and this is how the deviation in the alignment will come into picture. So, instead of a shortest alignment, now we have an alignment where the deviation will be there. In the similar form, if our alignment passes through a land area which has certain problems, like the land is marshy in nature, or the land is having the material at the formation level where there are all chances of heavy settlement taking place, then it is always better to avoid this type of location and move through any other location. The other point is with respect to the land is the costly land. If this alignment has to pass say very near to the urban area and the cost of that land is very heavy, then the cost of acquisition of the land will increase. So, therefore, in this case it is better so as to omit this type of land, and this land can be used for other development purposes through which the revenue can be generated in different form, whereas the railways or the alignment of a railway can be provided very adjacent to this land where the land value is not that high as it is there when you have to pass it in the case of a shortest alignment. Now, in this diagram the same sort of the obligatory conditions have been shown. There is a point A which is to be connected to this point B, and if this is a condition where a hillock is there, then we have to pass through this hillock and we come to this point and goes to this one. So, what way it can be done? And instead of passing through this one, the one way is that we pass through the other side of the area, and then in that condition we have to look around for that location where a bridge can be provided. In this case, the bridge has been shown at 3 locations, that is B, B1 and B2. So, which location is going to be better? This is one another aspect to be taken into consideration. Here what we see is that in this case the bridge is oblique to the direction of movement of this river, where in this case this bridge is again perpendicular to the direction of movement at this point, and this bridge is again perpendicular to the direction of movement at this point. It means the length of the bridge at this location or this location is going to be a little lesser as compared to this location. But again in these two cases there is further difference. what we found is that this is being connected with C, and then there is a very small curvature by which the road comes to this bridge and it becomes almost straight at this location and passes it, and then again there is a curvature by which it reaches this location B. Whereas, if we look at this one, this curvature is the connectivity from this point to this D point is straight, whereas after that there is a curvature being provided, and due to this curvature the widenings have to be provided at this location, that is bridge. So, the size of the bridge is increasing in width as compared to the other location, and due to this curvature effect the length of the bridge is a little more than this length of the bridge. So, we have to look at this another aspect, which is economic consideration of using another technology by which we can just cross an obstruction and move to the other side. Now, while doing this, what we are trying to do is we are connecting at this point location C, or at this point a location D, or at this point a location E. Now, if we connect through this way, then what happens is these are the points of revenue generation, and if we can generate some more revenue while moving along that path, while moving along that alignment, then that is an additional advantage of that alignment. So, that is why most of the alignments are made or are fixed in such a way that they connect number of locations by which the revenue can be generated while moving along that alignment. Now, another aspect of the selection of any alignment is traffic. Now, traffic is the main substance of any alignment, because this is the thing which needs to be moved. In the case of traffic, it may be of any two type, it may be a freight traffic, or it may be a passenger traffic, or it may be a mixed traffic, that is a combination of both. Now, when a new alignment is being fixed, then it is a little difficult to understand, or it is difficult to estimate that what is going to be the traffic which will be moving along this alignment. In the very starting, the catchment area of that alignment is taken as 15 kilometers on either side. That is, if we take the intertransverse direction 15 kilometer distance on one side, on either of side, it means the total is 30 kilometer patch along the alignment through which the people will be coming, or through which the freight will be coming to this alignment for its movement. And slowly it is expected that this catchment will increase to a value of 25 kilometers on either of the side. It means in this case it will become 50 kilometers patch along the alignment, where the alignment is the central point of that patch. So, once this catchment area increases, it means the overall revenue generation is increasing. More of the persons who are coming to this alignment, or more of the freight which is being transported using this alignment, means the revenue generation is there, and therefore, this is going to be a more economical or fruitful proposition, so as to provide this alignment as compared to any other alignment. When we talk about this type of a traffic which is coming through this catchment area, the main emphasis remains here in terms of the volume of traffic. So, the volume of traffic is to be considered in terms of as we have seen previously when we discussed about the different routes, it is as taken gross million tons per year. Now, in the very starting, when the alignment is being laid, then how that volume is going to come? It is taken as a square of the population. This is the amount of traffic which will be using that alignment. These are some of the ways by which an estimation can be made, so as to find out what is going to be the value of the traffic which will be using this alignment. And another aspect related to traffic is the growth factor. What is the rate at which the area development is taking place? What is the rate at which it is expected to increase the traffic? These are the two things which has to be taken into consideration, and this will provide us another estimate of the future traffic which will be using this type of alignment which is fixed in this area. These are some of the things which we have to take into consideration when we talk about traffic. Another point is the type of the geometrics or the standards we are providing for that alignment. As far as possible, the standards should be such that they provide the most economical combination. The standards is a thing which can be placed at any higher level. We can go to a very high level, but as soon as we go towards a higher level, then the overall cost of providing a facility increases. So, it means we have to look at that standard which is acceptable, but at the same time it fulfills our purpose, and it also fulfills the requirement of provision of any alignment in an area. So, therefore, we have to look at this economical aspect or combination from different angles, like the first thing is the locomotive performance. We have to find out that the available locomotives to us and what is the performance of those available locomotives, what speed they can move, what is the total traffic, what is the total load which they can carry with themselves, what is their performance when they are negotiating a curve, what is their performance when they are negotiating any gradient, up to what distance they can move on those gradients or curves without losing their speed. So, all these factors have to be taken into consideration, and then only we should come to certain features or certain standards which can be fixed for any of the type of the element which is to be designed under geometrics. Like in the case of the gradient, it is important to fix the gradient as far as possible to a value of a ruling gradient which is related to the locomotive performance. As far as a ruling gradient is provided, there is not going to be a much loss in the locomotive performance, but as soon as it is higher or steeper than this one, then the locomotive performance will sharply reduce. Similarly, in the case of the curve, as far as possible maximum radius should be provided. When there is a maximum radius, then the loss of tractive effort will be minimum, because the angle by which it is getting steered with respect to the angle in which the tractive effort is acting, that angle will be very less, and due to that reason the loss of tractive effort will also be lower. So, whatever maximum radius can be provided is another important aspect, and both of these things are going to create an effect on the overall weight of the train as well as overall length of the train which can move on that section. Then similarly, if there is any requirement of providing a reverse curve, then it is important to provide a 36 meter long chord between two reverse curves. This is another aspect related to the geometrics. Then in the case of the stations or in the case of the bridges, as we have seen previously in one of the diagram where we discussed the three locations of the bridges, as far as possible the track should be straight in nature and the train should come straightly on stations or bridges. The curvilinear nature of a track near stations or bridges is not desired. Another aspect from the economy point of view is the rise and fall. There should not happen that the whole of the alignment is being constructed in overall rise or the whole of the alignment is being constructed in fall. The requirement of providing an embankment or the requirement of cutting, both of the things are costly affairs, whereas the cutting is a more costlier condition as compared to filling. Therefore, we have to balance out the total quantity which is coming out from cutting and which is required in filling, and it is how the rise and fall has to be balanced out as far as the material considerations are concerned, as far as it is possible. If it is not at all possible, then only the cost escalation may be allowed. Then hauling distance is another aspect of the geometric standards, and hauling distance means with the help of the power available to any locomotive for how much distance the load can be transported, and that is what is the hauling distance. So, if we are talking about any locomotive which is running with some fuel, then with the capacity or the fuel which is provided to that locomotive, what is the maximum distance up to which it can move. Subjective, it is being offered by the resistances by the track or the resistances by the atmosphere or so on. So, looking at all those practical considerations, the overall distance up to which it can move has to be found out. So, they are all the points of standards by which it is to be designed so as to achieve the economical design. Then another important aspect which needs consideration is topography of the country. Topography of the country means the amount of undulations through which an alignment has to pass. On the basis of that undulations which can be there may be different type of alignment conditions. The very first one is the plane alignment, where the flat terrain is being provided. A flat terrain means the undulations remains more or less within a value of something like 10% as in the taken in the case of road segments, but here we can say that the cross gradient which is provided is coming within 10% value, and in such cases there is no problem at all. The another type of alignment is termed as valley alignment. Now, in the case of valley alignment, what happens is that the control points or the section through which on which this rolling stock is moving, that lies within the same side of that valley, and this is what is the valley alignment. So, the control points lie in the same valley, and we will found that there is a uniform gradient, means the 2 points which have been provided on the same side of the valley have been connected by a straight line for, and this gradient which is provided is generally a gradient which comes within the ruling gradient condition. Therefore, there is no requirement of having a steeper condition in this case, and this is what is the valley alignment. Then there is another category of alignment. This category of alignment is known as cross country alignment. In the case of cross country alignment, there are possibilities of having sags, means the depressions, or the summits, means the top points through which the alignment will be passing. And in most of the cases, these sags or summits, they comes into succession. The reason behind is that this alignment is crossing the watershed areas of 2 or more streams. Now, watershed area is the point through from which the water moves on either side of that section. So, therefore, if the alignment is passing through this one, there is no problem of water logging, or there is no problem of drainage, or there is no problem of the flooding taking place along this alignment. But in this case, when it is passing through this type of watershed condition, then there are all chances that it comes across through sags and summits, and that is why the sags and summits will remain on this alignment in succession. The another type of alignment is a mountain alignment. This is the topmost condition as far as the gradients are concerned. Here the alignment is increased in distance because the gradients cannot be fixed within the rolling gradient condition. So, in this case, the limit of gradient up to rolling condition or gradient probably cannot be filled in. So, therefore, we have to provide in between at some locations a steeper gradient than this one, but then if the rolling gradient is to be maintained, then the length of the alignment will increase. And as we have taken an example, that if we have to connect a point which is provided at top of the hillock, and there is another point which is provided at the foot of the hill, then a circuitous route is to be provided so that it remains within the rolling gradient, but then it increases the length of that alignment. Now, in the case of mountain alignment, because there are different type of conditions which can be there, and we have to come across of all those conditions, the different type of mountain alignments are available. And in those types of mountain alignments, or in those types of different developments, the first one is termed as jig-jag development. A jig-jag development is a condition which is more or less like a half circle loop. What happens is that it starts from one point, it tries to cover up some of the contours of the topography of that area, and then it returns back in a circuitous move on the same point itself, but at a higher level. So, this is how a half circle loop is completed, and then it will be moving forward in a similar form, maybe in the same direction or maybe in the other direction, so as to make a reverse curve condition. And it follows the side of the valleys, or at times it also moves around the hillside. So, these are the two possibilities which can be there in the case of zigzag development. Now, here in this diagram we are trying to show the zigzag development. What we are trying to do is that these all lines, they are the contours, and the values have been shown along all these lines, which shows that when we are at this level, it is 65, 70, 75, 80, means it is increasing in this direction. Similarly, when we look at this direction, then it is also increasing in this direction. It means we are increasing the height of the point in this direction. This is a higher point as compared to this point. Similarly, this is another higher point as compared to this point. So, when we are going for a zigzag alignment, then this alignment tries to follow the contour as far as possible. So, what we see is that this railway line or this alignment is coming from this direction, and it is coming in this form, and then we see that the contour is taking a turn. So, it also takes a turn in the similar form, and while doing so, it is going very close to the another contour now, and this is how it is taking elevation. So, now slowly and slowly it is going up, and probably the limit of the rolling gradient is being maintained. So, it comes up to this point, and then again here we found that it is taking a turn. So, we use the turn of the natural contour, and by which we also turn our alignment, and this is how further we can attain the height. So, this is overall zigzag process by which we can move in the forward direction. Then another type of mountain alignment is termed as switchback development. Now, in the case of switchback development is a case where it is not at all always possible to follow the contours as we have seen in the zigzag condition. So, what we have to do is that some steeper slopes have to be negotiated, and so as to attain those steeper slopes, we require certain position where the locomotive can come to a plain area, and then it generates further power, and using that power it goes in the other direction and takes the elevation. So, in this sense it requires two types of things. One is it requires a switch where from where it will be taking a change in the direction, and it requires a buffer stop, that is a point up to which it goes and stop and takes a change of direction, and then it starts moving in the other direction. And this type of development where it goes in one direction, it stops, and then it starts coming in the backward direction and opposite direction, it due to this reason it is termed as switchback development. Now, in this diagram what we see is the switchback development. Here what we found is this is the lowest contour on this side and the highest contour in this side. Therefore, we are trying to move in this direction. As far as the shortest alignment is concerned, we could have provided a straight line from this point to this point, but then it is observed that because of a shorter distance of this one, probably it will fall outside the limits of the rolling gradient. Therefore, we have to follow the contours, but at the same time the steeper values have to be attained. So, while starting from here, our track comes this way, it is more or less following the contours, and slowly it is going up, and this gradient is equal to the rolling gradient. Then it comes to this point, and then after this point it is going up to this level. So, this is the same contour. We can see that this is 70, this is 75. So, it is moving within 70-75 contour here. So, it is a leveled stretch. So, after a gradient, a leveled stretch is being given, and this leveled stretch helps the locomotive to attain the power back. And once it has attained the power, at this location there is a buffer stock. So, there is a switch at this point by which we are changing the direction. So, this is the direction of the locomotive coming in this way. and this is the direction by which it is going in this direction. So, this is switch here. Similarly, there will be a switch here, and there is a buffer stop here, means the train will stop by this end, and then there will be a change of the direction of the locomotive, and locomotive will take the train to this direction, and it will go up to this point, again will stop and will come this way, and this is how this keeps on going, and that is why it is termed as it comes this way and goes this way, switchback system. This is the same switchback system which is being shown here, the contours and along with the switching back condition. Then the another type of mountain alignment is a spiral or complete loop development alignment, where the complete loop is formed as a bridge spiral or a tunnel spiral. There are two types of spirals which can be there on the basis of the loop formed. Here we can see that this is a one photograph of a mountain alignment, where a specific type of engine is being used, and then the compartments which are used so as to ferry the passengers. This is also of different type. They are just due to attraction conditions. There is another this alignment being shown. The train is moving on this alignment, this mountain alignment condition. Now, here we are talking about a loop. So, what happens is that the track comes like this, and it is coming from this top area, then to this top area, and takes a turn this way, and then it has to go to the other side. Here there is a river on this side. So, it has to cross this hill, and it is crossing this hill by this dotted line. That means a tunnel is being provided in this location. So, this is a tunnel spiral, and then it goes in this form. This is another diagram where we see the bridge spiral, where it is coming back to the same location, and now it is going over the bridge in this direction. So, this is another alignment of the mountainous, that is of a spiral type of alignment. Here this is one photograph which is being shown. What we found is the train is coming from this side, then there is a bridge at this location, it comes to this way, and finally it is coming at the top and will be going in this direction. This is an old photograph being taken at Darjeeling area. This is another photograph of the same one. The train is moving in this direction, goes this way, and then there is another loop by which there is a bridge, and it will be coming in this way. Now, there are some more factors by which the alignment needs to be considered. One is the position of roads and the road crossings. So far it is possible, it should be minimum. Political considerations, at times we have to provide the alignment on the basis of the requirements or the wishes of the political or the government. Then geological formations is the another reason. We have to look for the good soil. It should be free from the drainage problems. There should not be rocks, and there should not be slips and slides in the area, especially in the case of hilly terrain. Otherwise the alignment will not be safe. And finally, we have to look at the hydrological conditions in terms of waterlogging, snowfall, or we have to look at the sun facing condition of the alignment. And the another important aspect is that the cost consideration, as we have discussed previously too, the cost consideration has to be considered at two aspect level, that is construction cost and operating cost. When the construction cost we are talking, then we have to talk about quarry locations, the height of construction, the labor, and then on the basis of all the cost and all the revenues which have been generated, we have to look at the returns, which is nothing but the revenue minus expenses divided by the total investment. So, what we have seen in the today's lecture is the aspects related to the geometric design, their elements, and then specifically regarding the alignment, the factors which needs to be considered while choosing any alignment. So, we are stopping at this point, and we will be continuing with the other lectures in the geometric design features in the following lectures. Goodbye and thank you.
Thank you.